Since it is wintertime, why is it so difficult to get a precipitation forecast nowadays?
What's up, guys? It's Kayla.
And Jim.
And welcome back to another Meteorology Monday. What are we talking about today?
Today we are going to talk about the difficulty when it comes to precipitation type forecasting in the winter weather season.
Yes.
So we've got your basic question. Is it going to rain? Is it going to snow? Will it be freezing rain? Will it be sleet? Will it be a mix of like
Everything?
everything?
Like 2 weekends ago?
Right,
Here
exactly.
in the Piedmont in North Carolina?
That's
We
right.
have experienced all 4 stages of winter weather precipitation grief in the past 2 weeks. And there's still snow on the ground. Now it's 50 degrees.
It's melting, it's slow death, which a lot of people down here are happy that the snow is going away. Some of us that like the snow. It's hung around longer than usual, and
Yes.
that is great.
It's great.
Bonus
Yes.
for this time of year. We are happy. If it melted today, we would be okay with it because we have just about a week of it so far. So
Yes.
it's been really good, not including this ice storm before. I'm talking about just snow.
Just snow.
So, but it's been good. You know,
Yeah.
this winter's been long, it's been
Yeah.
cold, and if we ended the winter right now with these 2 winter weather events, I'd be happy.
Pretty satisfying. Yeah, and then on Thursday it snowed all day randomly. We
Yeah.
got bonus snow. If only the South knew how to take care of the roads,
Yeah.
it could snow every weekend. But since they don't, and we have run out of salt and brine, I think we'll keep what we've got, and we'll see what comes the rest of the season.
So there is a lot that goes into winter weather forecasting, all sorts of parameters. We're not going to get into the nitty-gritty details in this video. We're just going to talk about the general setup for the different precipitation types.
Yep.
But before we get started,
If you find that you are enjoying this video along the way, be sure to leave a like and subscribe down below so you never miss the next Meteorology Monday. Before we get into the Skew-T diagrams and what these look like on soundings, let's define first the 4 types of winter precipitation.
they are snow, sleet, freezing rain, and rain. Now, we're not going to do hail for this video. That has different processes that go on and is more associated with summertime, even though it can occur in the wintertime. But we're going to stick strictly with the 4 precipitation types we just mentioned. Editing Kayla, could you please pop up a 2-dimensional diagram for us, please? This diagram is going to show on the bottom, that will be your horizontal axis or distance, and then in the vertical, or in the y-axis, that'll be going up in the atmosphere. Now for you meteorologists out there, I know what you're thinking. That's not the y-axis, that's the z-axis. Going in the vertical is the z-axis. You are 100% correct.
You are.
If you want to use the z-axis for that, go right ahead, be my guest. You're more technically correct. All right, so the easy ones are going to be the ones on the bookends,
Yep.
which is all rain, all snow.
Let's start with all snow. So for all snow, as you can see on this diagram, the atmosphere is a uniform below freezing temperature. So that is below 0 degrees Celsius or below 32 degrees Fahrenheit from the top to the bottom. And the precipitation that's falling has no chance to melt, so it stays as snow all the way to the ground. And on the flip side, for rain, it of course starts out as frozen precipitation because we're high up in the atmosphere, so it's below freezing up there, but it encounters a very warm layer of air all the way down to the surface, so it melts into raindrops, and it falls to the ground as rain. And fun fact with Kayla, raindrops are actually in the shape of hamburger buns, not emoji raindrops, because of physics and a bunch of other things. But there's your fun fact from Kayla for the day.
Let's get into the last 2, and that's sleet and freezing rain. And what I want to do is I actually want to have Editing Kayla show you the diagram, but I'm going to read to you what we put together for its definition. Sleet is where the frozen precipitation falls into a shallow layer of warm air in the lower atmosphere, called the warm nose, and melts well above the surface. As it continues to fall, it then encounters a deeper layer of sub-freezing air that causes the droplet to refreeze into sleet before reaching the surface.
You might notice a new word there called the warm nose. If you're on Facebook at all, I'm sure you've seen all of your local meteorologists throw around this word. It is, as you can see on this image, and what you'll see here in a second on the Skew-T diagrams that we're going to show you, that little nose of warm air is where they get that name. And it kind of like, here, can you turn sideways for us? There you go. There is a warm nose diagram here in real life.
So it's all snow here, it's sleet here, freezing rain here, and all rain right here.
On to freezing rain?
On to freezing
On
rain.
to freezing rain.
Freezing rain is where the frozen precipitation falls into a deeper layer of warm air in the lower atmosphere and melts above the surface. As it continues to fall, it then encounters a shallower layer of sub-freezing air, but is supercooled at this point, meaning it is still liquid, but in an environment of sub-freezing temperatures. Once the liquid drop hits a sub-freezing object at the surface, the droplet immediately freezes on contact, forming ice, hence freezing rain.
So, as Dad just said, this is rain that falls to the ground completely as liquid, but is technically below 0 degrees Celsius, 32 degrees Fahrenheit. So, when it hits an object that is also below freezing, turns into a layer of ice. This is where you get those really damaging ice storms like we had a couple weeks ago, especially if you've seen footage from Nashville, Tennessee, and a couple places in Mississippi, where this rain can coat the power lines and cause a lot of outages. It also sticks to my car and makes it impossible to get to work on time. But that's neither here nor there. Now, let's talk about Dad's favorite topic, which is thermodynamics. I'm going to kick it over to you to talk about these Skew-T log P diagrams and how we can tell precipitation type from balloon soundings.
Let's take a look at a Skew-T log P diagram, shall we? Editing Kayla? Basically, at the bottom you have temperature, and over on the left side, going up the left side, is logarithmic pressure. As one goes from the bottom of the image to the top of the image, you are going lower in temperature and lower in pressure at the same time. So how do we get these measurements? This is actually done by the National Weather Service, who launches balloons, and there's other entities out there. There's meteorology schools like UNCA that will launch balloons. They'll coordinate with the National Weather Service and be like, yeah, you know, we can launch balloons that are outside where the regular sites are. So where you need additional information, there's additional sites to launch balloons. So this balloon has an instrument package on it, one of those things being temperature and pressure. And so they launch it, and then it signals back to the radio antenna the information, and then it is collected in a computer, and that balloon goes all the way up until the balloon bursts, and then it safely comes back down. It's parachuted back down safely. Won't get into too many details with that, but this image here is a plot in the vertical of temperature and dew point temperature going at pressure levels. So as you can see, there are color shaded areas. One is the warmer tone, one is the cooler tone. So the warmer tone is temperatures at or above freezing. Cooler tone is temperatures at or below freezing. So this first image is a sounding that is completely below freezing. So this would be a profile for snowfall.
And throwing in my little bit of thermodynamic knowledge here, we can tell that it is currently precipitating on this because the dew point and temperature profiles, the blue and red lines, are close together.
The next image we're going to take a look at is where we start introducing more of a warm nose. And as you can see by the Skew-T log P diagram, you can see that there is a nose, hence what I demonstrated for you earlier in this video. Now you can see that the temperature and the dew point were in the cool shaded area, and then it happens to cross that melting line, and it comes in to the warm area a little bit and then goes back over to the cool side. And again, it is above the ground by quite a bit. So that is frozen precipitation falling in, melting, and then refreezing as it continues to fall, and that becomes sleet. That is a sleet profile.
Yep, and that cold layer near the surface is relatively thick compared to what you're about to see in the next couple images.
This is a temperature and dew point profile for freezing rain event. Like Kayla said, the two lines are very close together, so the humidity is very high, it's precipitating, and you notice that's an even bigger warm nose. No comments, Kayla. Frozen precipitation falls into that warmer layer, and then it actually goes back into a colder layer, which is much shallower, but that water is super cooled at this point. So then when it makes contact on anything at the surface that's below freezing, it'll freeze upon contact.
And last but not least, the all rain sounding. As you can see, it falls from the sky in the cold part and then crosses very quickly into above freezing temperatures, and it never goes back into a sub-freezing temperature layer. So it'll melt into rain somewhere halfway down into the atmosphere, and it will continue to fall as rain all the way to the ground.
And there you have just a high-level overview of different precipitation types, why they form, and also some of the difficulty as to, boy, you got to figure out, is there going to be a warm nose? How deep is that warm nose going to be? Will it stay? Just a lot of factors that go into it.
Yeah, this is a topic that can easily be expounded upon if you're interested in learning more about this and the nuances of forecasting winter weather. Because as you can see, the depth of that freezing layer at the surface and the depth of the warm nose, they can kind of overlap with the sleet and freezing rain profiles. And there's a lot that goes into figuring out just how warm the warm nose is and just how large it is, not only for in general, but for specific pockets, as it can change depending on your area. So your backyard forecast might be different than what the news is saying. So there's a lot that goes into it. If you're interested, let us know and we can make another video. But as for this video, there you have it, the different types of precipitation that can fall during a winter weather event. Again, if you like what you saw, be sure to leave a like, subscribe down below so you never miss the next Meteorology Monday. We're trying to get to 10,000 subscribers this year, so help us out, hit that subscribe button. As always, follow us over on our social medias, Facebook and Instagram. We post live when winter weather is occurring, as well as a lot of other things, so go join us over there. It's a fun time. If you haven't heard, we have merch! Meteotech Weather merch. We have sweatshirts, shirts, hats, everything you need to keep you warm in a nice winter weather event. Go check it out. It is the first link in the description box, meteotechweather.com. And until next time, I'm Kayla.
And I'm Jim.
Thanks for watching.
And we'll see you at the next Meteorology Monday.
So you never missed it. So you never missed.
We are starting the blooper reel, baby!